Hi, I'm Dan Sweet. I'm Director of Public Relations and Communications for Helicopter Association International, and welcome to our At Work webinar. Today's topic is avoiding the helicopter maintenance dirty dozen. Human factors always play a big role in the preventable accidents in our industry, and we feel it's vital to continue to talk about this, to address this, to bring this to people's attention. We recently held the Vertical Aviation Safety Team Global Safety Conference in the Dallas-Fort Worth area. And Jamie Dangerfield was one of our presenters, and I felt like his presentation was something that would be worth bringing to your attention today. So let's go ahead and get started. Our presenter, panelist, is Jamie Dangerfield. He is an Aviation FAASTeam Program Manager for Airworthiness. I'll give you a little bit more information about him in just a minute. He's with the FAA in South Carolina. Our webinars, if you're joining us for the first time, I know that the FAA has shared this link, and so we probably have a lot of brand new people on our webinar. These are interactive. We encourage you to ask questions. This might be one of the few chances you get to ask a FAASTeam member a question about the dirty dozen. So strongly encourage that. Please use the question module for questions. We do follow the chat function, but we give priority to the question module. That should be in the bottom of your screen, maybe on the side of your screen, depending on what kind of system you're using to view the webinar today. This webinar is being recorded. The link will be posted hopefully to our website and our YouTube channel within about 24 hours. I know that a lot of you are coming in here today to either get FAA Wings or FAA AMT credit. If you are trying to watch the recording, you will not qualify for Wings credit. You must watch this live. We do have to provide a report to the FAA tomorrow to show who all has participated in the webinar. It does also show how long you watch. So if you try to break away shortly, you probably won't get credit. If you do get kicked out and come back in, it notices that too. And so you won't lose any credit for something like that. Let me stop sharing here. Just real quick, I'll give you a little bit of a background on Jamie. He is, as I said, an FAA Safety Team Program Manager for Airworthiness in the South Carolina Flight Standards District Office, and has worked with the FAA for about 8 years. He also serves on the FAA Rotorcraft Collective Working Group. He has an inspection authorization, an airframe and power plant license, and a private pilot certificate with around 34 years of aircraft maintenance. Most of that working on helicopters for the Army National Guard, Rocky Mountain Helicopters, Air Methods, Omniflight, Merlin Fairchild Express, Heli East, and Carolina Helicopters. He also owned and operated Copter Doctors, a small public aircraft helicopter repair business in South Carolina. He has worked on the AH-1S Cobra, the AH-64 Apache, OH-58 Kiowa, Airbus AS350 A-Star, the BK-117, and Bell 206, Bell 407, and has flown a number of airplanes as a private pilot. He currently serves in the Army National Guard Signal Officer at the rank of Lieutenant Colonel in the Joint Forces Headquarters of the Deputy Signal Officer for the South Carolina Army National Guard. He has a Bachelor's of Science degree in Professional Aeronautics from Embry-Riddle Aeronautical University. Please join me in welcoming Jamie Dangerfield. Jamie, welcome to HII at Work. Thank you for joining us today.
Hey, Dan, thank you for the introduction. I'm excited to be here.
Hey, saw your presentation there in Dallas, and I just felt that this was something that we had to share.
Great, I appreciate it.
Please take it away.
All right, I'm going to go ahead and share that screen. Let's see. Okay, Dan, are you able to see my screen?
We see your screen.
Okay, I'll get rolling then. Thank you. Thank you for the great introduction. You covered most of my items, so I don't have to cover them. I am an Airworthiness FAASTeam Program Manager. Our basic job is to promote safety in the field from the FAA. We don't go out and inspect and violate people because we're designed to promote safety and encourage people to seek out safety and to ask for our advice when they need help to make sure they're following all the federal aviation regulations. I am in the South Carolina FAASTeam. My manager's name is Randy DeBerry. He supports all of these events. I really appreciate all he does. I do want to mention, if you could, have a screenshot program ready and running in the background. I have a couple of screens you may want to take a screenshot of. And let's see if there's any more information. Okay, we're all set. So the Dirty Dozen. So here's the background on the Dirty Dozen. I actually took the fixed wing Dirty Dozen and rewrote it to fit us rotorcraft helicopter guys and gals, because there's a lot of information out there about fixed wing, but very little about rotorcraft. So I took that template and I built this presentation. And I got to give Guy Minor credit with the FAA. He actually created the Airplane Dirty Dozen presentation. And like I say, I just stole from him and used his format. I did some really good accident investigations, though, to kind of make it interesting and to get everyone involved. So this first slide, it's basically saying I couldn't find a picture of anyone ejecting out of a helicopter, so I had to use this fixed wing example. Human error is both universal and inevitable. This means everyone will make a mistake sooner or later. In fact, the best people often make the worst mistakes. When learning of an accident caused by human error, it's common to think the person involved is somehow deficient in skill or character, while we, on the other hand, are well-meaning, motivated, experienced technicians. We just wouldn't do something that stupid. When we think in terms, we discount the moral of the story and miss the lesson in it. This is a picture of a spectacular accident caused by human error. The pilot started the loop about 1,000 feet, 100 feet lower than he should have been. So before takeoff, he set his altimeter to his home base. Even though this mistake was slight, setting the wrong altimeter setting, the outcome was tragic. So here's my question to the audience. Does the Air Force select mediocre pilots for the Thunderbird demonstration team? No, not likely. They choose only the best of the best. So why is this person making this mistake? Well, the Air Force selects people that are the best at their job to fly in the Air Force on Thunderbirds. So they pick them to do the riskiest jobs. The point from this can be taken that you can be the sharpest person on your crew, but if you had a sleepless night or someone doesn't give you vital information, then you may make a mistake. And sometimes even the slightest mistake can be bad. Okay, next slide. Okay, so maybe I did find an actual picture of someone ejecting out of a helicopter. Well, you can look at this picture and tell it's been doctored. It's a fake, it's not real. The door's still on the 206, so I don't think he really ejected. Someone, like I say, this is an April Fool's joke from a website called Rotor Floater. Okay, here's where I'd like you to take a screenshot if you could. What Dan mentioned earlier is I'm a member of this group called the Rotorcraft Collective. It's not just FAA, it's industry partners. This picture in this front, this one image you see here is actually a company called Rotorblade down in Georgetown, South Carolina. They actually have the saw blades that hang beneath the helicopter and cut power lines. So they were nice enough to provide some pictures for this video series. But please go and watch this. This is great for pilots and mechanics. This is actually one of the more popular Rotorcraft Collective videos. And I think it's because people are starving for information on maintenance. We do get a lot of information on pilots, but I think this series here is really interesting. And of course, it's called Pre-Flight Inspection After Maintenance. That also goes into an accident case study to try to make it interesting. Okay, so here are the helicopter Dirty Dozen, which are based off of the fixed wing Dirty Dozen. And so these are an example of a process came up with by Gordon DuPont working with Transport Canada. They went in and tried to figure out all of the human factors, errors that people make. And these were the ones they came up with. Now, you may have more than these 12, but these are an example of ones that we're actually able to identify a lot of accidents causes by. Okay, and this is our first accident case study. I'm going to try not to read the slides, but I will read this one because this is our key accident study here. On July 28, 2010, at 1:42 p.m., an Air Methods Corporation American Eurocopter AS-350B3 medical helicopter, November 509 Alpha Mike, during a VFR flight under Part 91, descended rapidly and collided with terrain in Tucson, Arizona. The aircraft was substantially damaged and consumed by a post-impact fire. The pilot and 2 medical flight crew members were fatally injured. The repositioning flight for engine coking maintenance originated at the Marana Regional Airport in Tucson, Arizona at 1:32 p.m. And the intended destination was the Air Methods base in Douglas, Arizona. A couple things I want to mention about this accident. I used to work for Air Methods, and it's a very professional organization. All of the case studies I did here are very professional organizations where the holes in the Swiss cheese just lined up perfectly for that day. And there were a lot of errors that took place that caused this accident. So just understand they're very professional organizations trying to do a job in a good manner and a safe manner. This is the actual accident aircraft. It was hard drumming up this picture. The NTSB actually helped me out with some of this information. This is an aircraft I'm very familiar with. I used to be a relief helicopter mechanic for Air Methods in Columbia, South Carolina for about 14 years. And of course, this is the accident after it happened, because you're probably thinking they probably auto-rotated, but how come they didn't make it? We'll go into a little bit of description of that in a few minutes. They did an external examination of the engine at the accident site, and it revealed that the fuel inlet union was detached from the boss on the compressor case. The fuel supply line remained attached to the union and the hydromechanical unit via the adjusted valve. The intermediate gasket was located in the fuselage debris directly below the union. And as I mentioned, this is what the accident looked like at the accident site. So let's go in and look and see what caused this accident now that you know what the primary cause was. Okay, this is lack of communication. This is the first of the Dirty Dozen we'll cover. This poster series is the same for the fixed wing as it is for helicopters. At the top of the slide, you're going to see all of the Dirty Dozen. The items going to be highlighted that we're covering in this example, lack of communication. And down on the bottom of the slide, you're going to notice it's got safety nets. Those safety nets are ways you can prevent those accidents from happening on the Dirty Dozen we're specifically covering. For example, lack of communication. The first safety net says use logbooks, worksheets to communicate and remove doubt. That is so important, especially with shift changes. That is something you really got to be careful about. Be specific in your descriptions too. Make sure if you're doing write-ups, you're very specific in what you do. Okay, let's start off at the beginning. So lack of communication between the FAA inspectors and the repair station. Okay, in 1953, the Civil Aeronautics Board, the forerunner of the FAA, required each operator to apply for an OPSPEX at the time of application for an air carrier air certificate. Those OPSPECs were used instead of competency or temporary letters. The OPSPECs provide an effective method for establishing safety standards that address a wide range of variables. And they can be adapted to specific types of certificate holders or operators class or size of aircraft. I'm going to let you know what an OPSPEX is a contract between the FAA and the operator. So I'm going to show you what it looks like, but here's what happened. The FAA principal maintenance inspector stated he removed the workaway authorization in 2008, but the owner of the repair station said he did not identify the change when he signed A004 on the OPSPEX. So here's what they look like. On the left, you see A004. It's A004 is basically a table of contents. Within A004, you see over here with the D100 that it points to, it describes it as performing work excluding continuous operations at locations other than at its primary fixed location. And when you go to D100, it's very specific on what they're allowed to do. So what this document is saying is, in shorthand, basically, this operator can do quick, easy maintenance in the field. And some of the examples used are change a tire, replace bulbs, do minor maintenance in the field with their repair station. But it does state they can perform work at a place other than its fixed location if issued these op specs, provided it has the facilities, material, equipment, and technical personnel to perform work authorized in the following table. Okay. But again, this is small, quick maintenance that they can do that happens to be small operations. They were doing heavy maintenance in the field is what we're going to get into. So that one is a lack of communication, of course. Not too much as far as a contract. It's not like one when you buy a car where you have 20 pages. The FAA tries to make them simple and short. Okay, next up is complacency. In the Dirty Dozen, you see the safety nets right there on the bottom. Train yourself to expect to find a fault, never sign for anything you didn't do. So I like to define this one. Complacency is caused by a lack of sufficient stress. We hear stress is bad for our health, and too much unresolved stress certainly is. However, we need a moderate amount of stress for optimum performance. While too much stress causes confusion and fixation, too little stress can be a problem as well. It can cause a person to be bored and complacent. I use the example of if someone's sitting in their basement watching TV and they don't want to get a job, that's complacency. They don't have the drive to get out there and get that stress of getting a new job, doing something unfamiliar. So that's a good example of complacency. So just remember that, complacency. Okay, let's get back into this accident investigation. As a turbo mecha service center, Helicopter Services of Nevada, which was a repair station doing the maintenance for Air Methods, provided levels 1, 2, and 3 maintenance, service parts, and tools. The Turbo Service Center technicians completing a turbo mecha design checklist and engine build form when performing field maintenance. Turbo Mecha does not require its outside service centers to document their work with the forms, and they are allowed to develop their own forms to document the work. So Helicopter Services of Nevada had developed their own work order forms and checklists that were completed when work items were accomplished. So I mentioned this earlier. They were doing unauthorized detailed maintenance in the field. And when they were in the field, they didn't have to do this work order form, which required a second person to look at the actual work. So because they weren't using that form, the A&P was signing off his work as an A&P and not signing off as a repair station in the actual facility. Let me rephrase that. He was actually signing off as a repair station in the field, but was not completing the forms because he was not required to by the repair station's documentations and manual they went by. Okay. And of course, as you see on the slide in the very last bullet, no final inspections are done when he's in the field. So that could be considered complacency by the Turbo Mecha Service Center, because they were doing detailed maintenance in the field, but they didn't use the work order forms. They weren't violating any regulations, though, as far as the FAA was concerned, or the individual wasn't. Let's move on to the next one. Okay, so complacency. Here's some safety nets. Face reality, physical fitness, create challenges for yourself, train yourself to expect to find a fault. And there's a couple others there. Okay, next up is lack of knowledge. It may seem lack of knowledge is about being inexperienced. However, the rational point of view is that aviation is incredibly complex. No one has all the answers. We all lack knowledge in tasks that were not familiar to us. Even experienced people need to refer to update manuals and ask questions. I learned this in my early career. Be modest, ask a lot of questions, learn from those experts and make them into mentors. That is really the best way to learn. And that applies to pilots and mechanics. Go to someone who's successful and does a really good job and try to learn from them. Okay, lack of knowledge. We're going to hit the pilots up on this one. So after all that heavy maintenance was done, the maintenance test pilot went out and did a ground run of the helicopter. After the ground run, they found out the engine's hydromechanical unit was found to be leaking. The next day, they fixed the leak and the pilot performed a ground run. They have a digital system that recorded his run called the AVL hub interface. And then he did his flight. And that was also recorded in the AVL hub interface. According to the pilot, the following checks were performed. And you can see that on the left side. He did a droop check, a rate of climb check, a cruise power check, a flight limit indicator check, a flame out check, auto rotation. Okay, so when they checked the AVL hub, because I don't think he documented the maintenance test flight in the logbook, they found out that that took approximately 7.5 minutes. Okay. Well, they went to the turbo mecha service experts that were a part of the accident investigation, and they said, look, what is required during an actual maintenance test flight after doing this engine coking repair? And they said, well, by the manual, you should do a hover flight check, a max continuous power climb, a max takeoff power check, a max continuous power level flight. And they estimated it would take around 30 to 45 minutes to do these actual things. So what am I saying by this slide? I'm saying if by chance the maintenance test pilot were trained properly and he'd have the right and went to the right checklist, he would have done that test flight in 30 to 45 minutes, and it would have failed while he was flying it in an area that was probably safe for an emergency landing, like an airport, and this accident might not have happened. Again, I mentioned to you the Swiss cheese. There were multiple holes all lined up that caused this accident, and all of them applied to different human factors. This one happened to be lack of knowledge. And here are those safety nets for lack of knowledge. And you can see a lot of these apply here. Get training on type, stay current, read. Ask a tech rep or someone who knows. And you got to put yourself in the shoes of the maintenance test pilot who test flight. He was probably trying to save the company money by saving hour cycles and fuel costs. His motivation was in doubt. His method leaves a little bit to be desired. So always make sure you follow your checklist. Okay, next up is distraction. Does anyone out there happen to have a cell phone nearby? Well, mine are all on mute, but they do go off while I'm doing these presentations with, they vibrate. Of course, you can't hear it on your end, but those cell phones are a distracting feature of our culture. When you're driving, listening to a speaker or maintaining aircraft, it can really be disastrous if you get distracted by a cell phone. That's just one good example that we have to be very careful with. The safety nets, I'll give you an example. If you receive a call when you're on the ground, maintenance guys, there's an example here on the slide down at the second to the last bullet. If you receive that call, I would always recommend you go back 3 steps. That's a good example of what you can do when the cell phone goes off. Okay, here's another example. On September 16th, 2017, at about 4:35, a Bell 206 Long Ranger 3 helicopter, November 213 TV, or Tango Victor, impacted terrain near Ancho, New Mexico. The pilot was the sole occupant, was fatally injured, and the helicopter was destroyed. It was a flight that originated at around 3:54 p.m. from Roswell International Air Center Airport in Roswell, New Mexico, and his destination was Albuquerque International Sunport. So let's review the slide. He was returning a cross-country business flight in a helicopter, and the weather was beautiful. As you can see by that slide, in the background, it was probably that beautiful of a day there, where it was just sunny and there weren't many clouds in the sky. But they went and did the accident investigation. Well, let me go back to this. The second bullet, the last 5 minutes of the flight, the helicopter's GPS altitude varied between 6,200 feet and 6,456 feet. The terrain in the accident area was between 6,000 and 6,400 feet. The impact point was at 6,330 feet. Okay. They went and did the accident investigation, all the NTSB, the FAA, and all the other parties to the investigation. And they just happened to find his cell phone. And it actually was able to be, the information was able to be downloaded and accessed. They found out from this phone that he made a phone call at 4:12 p.m. Now, this is while he was flying the helicopter. And he called a rental car agency. Now, I will tell you, this was not wired into the aircraft. This was a loose cell phone that he called while he was flying this helicopter. So they went and talked to the rental car agency lady, and they asked her, and they said, "What, do you remember this call?" And she said, "Sure, I remember that call." She added that she could not tell that he was in a helicopter, but he seemed busy or distracted. And that as they were talking about a future rental, and she was mid-sentence, the line was disconnected. Okay. So she noticed he was busy or distracted. And guess what? Based on that call, the pilot was likely using his cell phone during a low altitude flight and became distracted, which resulted in controlled flight into the terrain. This pilot was very, very low to the ground when he was flying and got so distracted by his cell phone, he flew it right into the ground. So what I'm saying here is, and this is for the pilots and mechanics, and we may have some student pilots out there, when you're flying a helicopter, you're busy. You got your right hand on the cyclic, you got your left hand on the collective, and you got both your feet on the pedals. I'm still trying to imagine how this guy was flying his helicopter. He probably tightened down his collective friction, had everything set on the collective, but I just can't imagine trying to fly a helicopter and talk on a cell phone. That would be tough. I would say if you do that, make sure you have an installed cellular system that you can use through your headset and probably some switches on your cyclic that you push the button to actually talk with. They actually have STCs out there for that type of installation. Supplemental type certificates, in case you're not aware of the acronyms, which allow you to modify your aircraft. And here's some safety nets when you get distracted. I mentioned a couple of them already. For example, if you're a maintenance guy and you're working on fuel or hydraulic lines or pneumatic lines, and you get pulled away from it and you haven't finished the job, go ahead and loosen the connection completely or finish the connection by torquing the line. We've had a lot of accidents occur where people got pulled away to help someone else and they forgot to tighten that line and it caused problems. And of course, there's a couple other safety nets here. All right, the next one we're going to cover is lack of teamwork. I've been guilty of this. I've had something happen one time where I worked with an unfamiliar team, and we forgot to tighten up a fuel line, and we had a leak on run-up, which was good because it was before the flight, so we were able to fix that. But let's go ahead and talk about our accident case study on what happened here. Okay, so as you see by the main bullet, lack of teamwork may have contributed to a process error. So between July the 24th and July the 26th, the accident engine was disassembled first, and the mechanics realized they would need additional parts and tooling to complete the work. So just to stage this for you, you have 2 Air Methods mechanics and you have 1 Helicopter Services of Nevada mechanic working on that first helicopter, which is the accident helicopter. Well, they got to a point where they had to set the original accident engine apart or set it aside, and they started working on a second aircraft, okay? But when that happened, the Air Methods mechanics went over to the second aircraft to work on the second engine, and the Helicopter Services and Nevada mechanic kept working on the original accident aircraft by himself, or engine by himself. So the HSN repair station technician replaced the fuel manifold on the accident engine. And during the work on the accident engine, the Module 3 was disassembled, the fuel injection manifold was replaced, the engine was reassembled by the HSN technician, including the fuel inlet union, and then the engine was reinstalled into the helicopter by the Air Methods maintenance personnel. The HSN technician inspected his own work, and he was allowed to do that when he was away from his fixed location, and gave him the authority to do that inspection. So here's some information. We mentioned this earlier. These bullets get into the meat of what I just discussed with you. But here's the question I want y'all to ask yourselves. What would have happened if the repair station mechanic asked the air methods mechanics to check his work before assembly? Okay, we're talking about the holes in the Swiss cheese again. He did not ask for their help looking at the work that he had done. This is where I've learned in my career, be humble, be hungry, and always have someone check your work if you're going to cover it up. You don't have to do it. If you've got your A&P or you're working for a repair station in the field like he was, you don't have to do it, but I highly recommend it for your safety and the pilot's safety. Okay, so here are the details of the accident when they did the investigation. In these pictures, you see the as of or as received accident parts are displayed in the upper view figure number 1. So that's up here, number 1. The lower view shows a close-up of the area where the fuel inlet line, the fuel line with the jet union is attached to the diffuser assembly with the copper gasket between. You can see the copper gasket right there. The components were intact, but reportedly found disconnected at the jet union to the diffuser connection. Note that the bolts and screws and nut hardware were not found at the accident site. So you know how a helicopter vibrates, it vibrated all the hardware off because it wasn't tightened all the way. You also see on the bottom right corner, there's a parts breakdown out of the Turbo Mecha parts manual. These are the actual examples of the components that would have been there if they were all found. Those are called exemplars. So you can see the bolts, the nuts, the self-locking nuts, and of course the copper gasket. If it were brand new, that's what it would have looked like. So lack of teamwork, communicate. Team tasks require a full team. Don't be proud, be humble. Always ask for help. And here's another thing for all those field mechanics. I know there's mechanics out there in field locations by themselves. Get the pilot to check your work before you cover it up. They might want to work on their A&P anyway, and so have them go to the manual, look at your work, show them the work you did, and teach them. It will pay off in the long run, believe me. You'll have a much safer pilot who really knows what to look at, and it'll also help you understand the process too. Okay, next up on the Dirty Dozen is fatigue. We're going to cover some generic information here. There's 3 different kinds of fatigue by the medical community: acute fatigue, chronic fatigue, and operational fatigue. Acute fatigue is usually where you might have missed one night's sleep. It can be, you can recover after maybe just a single rest period. Chronic fatigue means you may have a medical problem. You may have restless leg syndrome, or you may have to use a CPAP machine to sleep. It can cause depression. Operational fatigue is where anybody works too many days in a row, gets too little sleep, and it can't be relieved by a single sleep period. I know I've worked long hours and days, especially in the National Guard, and it usually takes me about 2 days to catch up on my sleep when I've had a lot of that operational fatigue. It's probably going to be the same for you. The symptoms of fatigue. I've always noticed, for example, when in the military, when we've been up for like longer than 48 hours with no sleep, you start noticing people start slurring their speech, and all of these symptoms right here you become aware of. Usually the person who is not suffering from fatigue but sees the person who is the one who recognizes the person's fatigue. Now, here's an example of how fatigue affects your body in comparison to your blood alcohol level. So this is just a comparison chart, and it is just, it's subjective, so just understand that. So if you look at the slide over here, if you've been awake for 17 hours, it's like having a 0.05% blood alcohol level. If you've been awake for 24 hours, it's like having a 0.10 alcohol level. And as you can see up here, just 0.05, you're impaired, you're considered impaired in all of these countries. In the US, if you've got a 0.08, it would be the US would consider you impaired, Brazil, Canada, Ireland, and Singapore. So that's just an example to say, this is the effects of fatigue on your body. Now, we're going to cover this on the last couple of slides, but this was a fatigue issue that we're going to cover real quick. The helicopter you see up there on the top right corner is the helicopter that did crash. So when they did the accident investigation, they went in and interviewed the mechanic and the inspector because they had made a serious error of judgment and inspection when they had done the maintenance. On the particular day they were called in for this maintenance, they were not normally scheduled to work this shift. As you can see by the slide, their normal shift in the second column was going to be from 12, which is lunchtime, until 11 p.m. at night. They were normally scheduled to be off on the day they were called in. But as you can see by the slide, the mechanic ended up working right before 6 a.m. all the way up until almost 7 p.m. The inspector worked from 5:30 a.m. all the way up until almost 7 p.m. The mechanic only got 5 hours of sleep. The inspector got 7 hours of sleep. And I'll cover this accident case study here in a few minutes. That's just to wet your whistle. Circadian rhythms. So we're going to cover a little bit about circadian rhythms. So the reason there's some pictures on the slide is because the Marines did a study to see if they could adjust your circadian rhythm, which is your body's sleep cycle. So you notice when you travel overseas, you have to get on the same sleep cycle as where you're at. And if you go, say, for example, to France or England, you're 12 hours difference. You're awake when you normally would have been asleep. So this circadian rhythm is very important for your body. The Marines did this study to try to find out if they could adjust it quickly in their Marines, and they found out with no success they couldn't modify it any quicker than the standard methods most people use. For example, your circadian rhythm affects your biological clock. It is affected by temperature, blood pressure, heart rate, and also you'll notice, for example, the people always mention when you go to a foreign country where you have to adjust your sleep, you need to go out in the sunlight because that helps adjust your circadian rhythm. In this slide, you'll notice in the green chart, your best time to work is from 8 a.m. until about 4:30 p.m. That's when your performance is at peak. When you get into the midnight hours, your performance goes way to the bottom, as you notice by the arches there. So fatigue, here's some safety nets. Be aware of the symptoms and look for them in yourself and others. And I'm going to skip around here, look at the bottom, ask others to check your work. Next up is lack of resources. We're going to go back to our original accident investigation on that one. Of course, resources are money, which affects your parts, people, time, tools, and data. Those are all resources that you need at your disposal when you work on an aircraft. There's your safety nets at the bottom. You're going to notice these safety nets were not followed in this accident. For example, if your aircraft is down, order the parts ahead of time. And just, yeah, those are great safety nets for this accident. Okay, so back to the original accident investigation. Lack of resources may have contributed to a maintenance process error. If you'll remember my description earlier, I mentioned to you that the accident aircraft was disassembled by all three mechanics. But guess what? They realized they didn't have the parts or tooling to complete the work. So they set the aircraft accident engine aside, and the HSN technician continued to work on it while the Air Methods mechanics went and worked on a different aircraft. So if they would have had all the parts and tooling available, they could have finished that first job on the accident aircraft as a team. So I'm going to say lack of resources leads to a maintenance process mistake. Again, another slice in the cheese lining up. The good question we all need to think about at the bottom is, what would have happened if they had the correct resources? And we kind of just reviewed that. There are your safety nets for lack of resources. Again, that second one or that first one would have affected this event if they would have done this ahead of time. Now, it is hard sometimes to always know what you need, but if you're able to know what you're doing, like engine coking, you should be able to go in and look at the maintenance procedure and figure out what to order. There's your I'm sorry, the next one is going to be pressure, and there's your safety net for pressure that's coming up. Just to make you aware, a certain amount of pressure is appropriate, but too much pressure can cause a technician to make a mistake. If there's a generic hazard in aviation maintenance, it would be pressure to produce. Pressure causes a drift to dangerous methods. Back to our original accident case study. So the mechanics felt pressure after the first engine run up after maintenance. So when they did the accident investigation, they interviewed the pilots, and they found out that the Air Methods chief executive officer was coming in for a visit. The base was out of service, and they didn't have a backup aircraft to use at Douglas. I learned this working for Air Methods. They would take the primary aircraft, send it to the maintenance base up in Greenville, South Carolina, but they would bring a loaner in, and we would move all the medical gear over to the loaner aircraft to cover as a backup until the original aircraft had all the maintenance done. That's just the same thing they were trying to do here, but they couldn't because they didn't have a backup available. Now, what they did say, so here's the statement from the Air Methods Area Aviation Manager. There's some internal pressure on pilots and mechanics because they know if they're not getting enough flight volume per month, for example, 10 or less, then their base may be considered for closure. All the bases in the southern Arizona area were doing okay, though. So this might have been a pressure item, but not necessarily. It's all what the person perceives. Okay, here's your safety nets for pressure. Be sure it's not self-induced. Communicate your concerns, ask for extra help, or just say no. Next up in the Dirty Dozen is lack of assertiveness. Mechanics as a group are not as assertive as we could be. We like to fix the airplane or fix the helicopter and leave the conflict to the managers. We have a can-do attitude, and we really do. Here's the assertiveness U-shaped chart. I'm going to just review this real quick with everyone. And it really helped me understand the process of how you can evaluate assertiveness. Over here on the left side of the chart, you see low in red. And then you see performance over here on the left side. Well, if you're going up the chart, you're moving towards high performance. At the bottom, you've got passive and you've got aggressive over here on the right bottom corner. If you're passive, you consider other people's rights before your own. If you're aggressive, you consider only your rights. The best place in this chart, I'm gonna pause for a second. Where do you think it is? Well, as you already know, it's in the middle top. You do consider other people's rights, but you also consider your rights and your knowledge in making a decision. So we need to be in the middle if possible. These are some pictures, and not to do with helicopters, of course, of accidents that were caused by people not being assertive, okay? The top right is Tenerife, Spain, where the two 747s collided because of some communication errors and lack of assertiveness. Next up is stress. Stress is a blessing and a curse. We need it. Like I said, we need it to pressure us to do things that need to be done, and we need a little bit of stress. We don't need too much. Here's a U-shaped chart that is exactly the same as the one we just covered. You want to be in the middle. You want a moderate amount of stress, and you want high performance. Here are the symptoms of low stress: complacency, and over on the right side of the chart, you see fixation and confusion. here are the safety nets for stress. I'm going to just mention this one to everyone because I love this one as a helicopter mechanic. The fourth from the last bullet, or I guess the fourth bullet from the top, take time off or at least have a short break. I remember working on Cobra helicopters way back in the day, and in the ammo compartment, we would sit on our backs and loosen 65 screws. With back then we didn't have many drills. We usually used not a screwdriver. I can't remember the term, but we used you spin the little screwdriver and take it off with that. But your arms were so tired holding that screwdriver up in the air that you had to take a break, or you were doing something like working on a fitting that's in a really hard place to access. Usually if you go take a break and you come back, you're able to put that fitting on. So those are some good safety nets there. Lack of awareness is the next one. Okay. Lack of awareness or reduced situational awareness can be an indication one or more of the human factors issues are in action, such as fatigue, distraction, or lack of communication. Here's an example of how the lack of awareness caused some serious damage. Okay, well, we're going to say this lack of awareness did cause some damage, but there'll be some contention about this assumption made by the NTSB. So lack of awareness. So the aircraft was operated just below max gross weight. It had 90% of required fuel for a 2.5-hour flight, but the flight was only 55 minutes. Could have been a problem during auto rotation. Something I did forget to mention to you in that original picture of the accident, when they auto rotated, they did hit that concrete wall, and they didn't quite make it as far as they needed to prevent hitting that wall. And that's what caused the explosion and the fire to happen that caused everyone to perish. So the other issue they weren't aware of until the accident, they found out that it had overflown the cycles on the aircraft for an AD, an airworthiness directed by the FAA, mentioned there at the bottom. The engine inspection required an inspection at 500 cycles, but the engine had accrued 515.28 cycles. Now, another item that was found during this accident, and this is the interesting part of these accidents, you find out all these items contributed to the accident. The rotor RPM gauge location, it was installed in the bottom left-hand corner of the instrument panel. Technically, it would be the middle lower part of the instrument panel, the way we're looking at it here, which was non-standard according to the manufacturer. Now, all the pilots out in the field that are listening to this briefing know that when you do an auto rotation, that RPM gauge is critical. Well, you're flying the helicopter, you're trying to pick out a landing spot, you're worried about your passengers, and you're looking down below your left knee to see if you've got the NF and NR gauge in the right location so that you can actually do a correct auto rotation. When they did the investigation, they couldn't find any documentation like a Form 337 showing that the instrument had been moved. So that was another one, lack of awareness. Next up, we have another accident. This is a separate accident where a commercial pilot was performing external load operations in a helicopter when one of the main rotor blades separated, resulting in a loss of collision or control and collision with terrain. The helicopter rolled downhill and the airframe sustained substantial damage. When they did the inspection, they found 4 of the main rotor blades were fragmented into many pieces, but the 5th main rotor blade was about 900 feet from the wreckage. They found out there was fatigue cracking that had initiated near the root end of the blade. This was a circumstance, and I'll review this on the slide. The aircraft pilot had an airframe and power plant certificate. He received it so he could do the torque event inspections, which is very noble. But as we all know, when you're out remote by yourself, a company loves it when you have a pilot certificate and an A&P, because they can get one person to do 2 jobs and only pay them 1 salary. So in this case, the airworthiness directive said that the blade had to be inspected after every 200 torque events. It required the operator to record the number of torque events on each main rotor blade. But when they interviewed the pilot / A&P, he said he usually exceeded 200 torque events per hour and didn't perform the inspection until he got home at night. Ooh, not a good idea. This is what the rotor blades look like. Now, it was a blessing he was in a Hughes 369 because it rolled downhill, which probably saved his life. Any other type of aircraft, they may not have survived. Lack of awareness. Think of what may occur in the event of an accident. Yeah, this was definitely one of those deals where he could have prevented it if he was following the AD requirements. And norms is the final one we're going to cover. All right, let's go back to the one we covered earlier about the two people who were fatigued and didn't get enough sleep. This is a tourist flight that ended abruptly. A series of maintenance errors was responsible for the crash of the Sundance helicopter, which is another American, Eurocopter back then. Now it's Airbus, that crashed in the mountains of Las Vegas, the National Transportation Safety Board says. And of course, they mentioned maintenance was one of the issues that caused the accident. And here's what they said. The NTSB said that the maintenance people and the inspector failed to carry out maintenance, proper maintenance, and failing to do necessary actions. So what happened? The organization at the time, the mechanic, this is all assumptions now because I wasn't there, but from the investigation, they found out that the fore and aft servo came disconnected. And what happened was the nut just backed out, okay? And nuts don't back out unless there's a problem. Well, that's because there's a cotter pin that's supposed to be installed, and it wasn't. You can see by this example on this slide, right there in the picture, that's the way it should have looked. Well, when you do an accident investigation, you find things that tell you what caused the accident. We'll see a picture of that in a minute. And of course, they found out that the organization reused a degraded self-locking nut, and they did not install a split pin or cotter pin. And of course, you had an inspector who inspected the work. They mentioned the post-maintenance inspections. Now, I'm going to say the mechanic missed it, the inspector missed it, and the pilot missed it. So there's three people that could have caught that split pin being not installed. So the contributing factors, as I mentioned earlier, were fatigue. They had a lack of clearly delineated steps for maintenance task and inspection, the NTSB said. Here's that picture of the accident scene. And as you can see by the red arrow in the bottom left corner, that's where that fore and aft servo would have been connected. Norms. Always work per your instructions or have the instructions changed. That was really important. They're not reusing that self-locking nut probably really was the primary factor. And of course, leaving out the cotter pin was what caused that accident. And the lack of rest, fatigue. They were fatigued, so they probably were tired and missed it. If you have a way to do something, say, for example, they have this picture on the slide. If you have a way to do something, it can be done that way as long as you go to the manufacturer and get the FAA to approve it. Otherwise, you have to follow the maintenance manual. There's the Dirty Dozen in the movie that it's based on. Face reality, what you do as a mechanic or a pilot can cause death and destruction. So make sure you're doing the right thing always, letting people check your work and being safe. The Charles Taylor Award is given to mechanics with 50 years of maintenance experience. You can either do it in the military or as a civilian. If you do it in the military, you can count 20 years of that experience towards that Charles Taylor Award. Why is he famous? Because he helped build the engine in 6 weeks from scratch for the very first Wright Flyer that the Wright brothers flew. The automobile manufacturer said it couldn't be done, but he did it. Dan, that's all I've got.
Okay, Jamie, gosh, I appreciate that. That was every bit as interesting the second time I've seen this now. The first time, again, was at the VAST Safety Conference, and that certainly was an interesting event there in Dallas. We don't have a lot of questions coming in. One of the comments I did see was the tool you were talking about was a speeder or speed handle.
Yeah, speed handle. I drew a blank on that one. I've used them.
We've got a fairly significant group of maintenance guys in here, and so obviously some people are very familiar with it. Hey, the factors you just went through are literally part of our everyday life anymore. And, I might experience literally all 12 of them just hanging out with my family, or especially if I'm taking a drive with my family. So it really is all about context. You mentioned, the fact that people can go to work and, if they're experiencing this, people can die, things can fall out of the air.
Oh yeah.
Is asking for help when you need it, when you recognize these factors, is that a sign of confidence or is it a sign of weakness?
No, I would say it's a sign of confidence, because you feel like you want your work checked, because you can make errors. I mean, anybody can make a mistake. Anyone that says they don't make mistakes is lying. So I would say it's being humble, and it's being hungry to learn, which is what you need to be in aviation, because none of us know all the answers to everything when we do maintenance. We really have to learn from other people and follow that manual. So a very good question, Dan.
Well, and then you mentioned the situation there in the Grand Canyon with the two mechanics, both of them who had been working longer shifts than expected. They came on early, worked all day long, may not have had enough sleep, but they obviously were called back in. So many of the safety nets that you mentioned, we're talking about asking for help. How do you figure out who to ask? I mean, I don't know that if I was working alongside somebody, I would think to ask somebody else, but if that guy is just as tired as I am, what's a good rule of thumb to try and figure out what you need to do there?
Sure. So, in that example, I would have grabbed the pilot. If the inspector and the mechanic were both exhausted, I would have grabbed the pilot and said, "Hey, you've gotten a good night's rest. Can you take a look at this for us? Here's what we did step by step. Take a look at it for us." I also recommend that you keep cowlings off before the pilot does the pre-flight. That is so important, because that allows him to see those areas you worked in. Otherwise, you'll have like a little panel you can open up, and you have to get a flashlight and aim it up in the area they worked in. But if you can have the cover off and let that pilot look at it, you're doing him a great service. Same thing with the inspector. Let the inspector look at it before you put the cowling on. And then, of course, have the inspector look at the cowling. I highly recommend that.
Okay. We have a question from Ronnie. Besides following the checklist or safety net guidance, are there other tools operators should be considering? Perhaps hums or digital record tools, et cetera?
Sure. Yeah, and those digital tools can really be helpful. If you've got a manual on a digital record like an iPad, those are great. Always make sure they have current revisions, though. But yeah, definitely, those are some really good points to think about.
Well, and one thought I had also is, again, knowing the fact that so many of these elements are part of our everyday life. It seems like we have become a much more intense society, and so things are just moving at a different pace. How do you ground yourself at the start of a day?
I apologize.
My last job, there was a
my dog's barking. I apologize.
Distractions.
Yeah. So Dan, I'm gonna have to close that door. I apologize. So for me, hungry. Well, I tell you, it never fails. Being hungry and humble. That's really the thing. Be humble. Ask questions. Learn from other people. Don't be too proud. The humble part really means a lot. I was very proud when I was a younger mechanic. I didn't want to ask for help. And I found out that created problems. As soon as I started becoming humble, I found out I became more successful. And people, when you go and ask them for their help, makes them feel better about you, in my opinion.
I could not agree more. I've solved so many solutions, especially interpersonal issues, by asking the person for help. Hey, this seems to be an issue. How do we solve this? How do we resolve this? Where do we go with this? That seems like it solves so many conflicts. We have a question or a statement from Conrad. I would almost like an ETOPS approach for maintenance with single engine or dual engine aircraft. Is there a push for a two-part look?
I'm sorry, I missed that last part, Dan. Let me turn my volume up where I can hear you a little better. What was the last part of that question?
I'll just go. It wasn't long enough. I would almost like an ETOPS approach for mechanics with single engines or dual engine aircraft. Is there a push for a two-part look?
Dan, I'm going to close that door. Hang on one second. I'm sorry.
No, I think this is a great indication, once again, of the dirty dozen, the distractions. And the fact that Jamie's mitigating the issue solves the problem.
Yeah, great question. So the FAA, and I learned this coming on and working for the Federal Aviation Administration, that we make rules when accidents happen and people die. Because our society is set up to where we do the minimum amount of rules, we trust people, and we give them the ability to do what they got to do. But I would say that when more accidents happen because you don't have that second look, that's when we change the rules through a process called the Notice of Proposed Rulemaking, and we actually change the rules. But it has to be a public outcry to do that, because we don't want too many regulations that overwhelm organizations that are trying to make a living.
I have a question from Nestor. He says, how do you mitigate what is related to the lack of communication factor?
Yeah, that's a good question. So shift turnovers are critical with maintenance. Shift turnovers, it could be in the middle of the day, it could be at the end of your shift where you're handing a half-done project to someone else. That's when communication is very, very important for a mechanic. Another example is when a mechanic does maintenance and he has a pilot come pre-flight, if he's just an A&P, he may want to go over and communicate to that pilot all the work that he did and show it to him so that he can check it. So I would say that's one of the most important things with communication.
Victor is asking about organizational maintenance training. Do you think that the lack of that kind of training affects the accident rates?
I would agree. And I would say that larger organizations have an easier time with training. And I noticed this with Air Methods and Rocky Mountain Helicopters. They did allow us to do a lot of training and get paid for it. But as an A&P, when you go out in the field and work, you're really training yourself and you're working with another mechanic in some cases. So always work with someone who's more experienced on the task and try to learn from them. Because when you're an A&P and you're out there in the field working on a helicopter by yourself, you don't always have someone you can ask, but you can always call another site and say, hey, can you help me with this task? I'm having a problem understanding the maintenance manual. And they will more than likely help you and be glad you called them.
Okay, I think that's about all the time we have for the day. I'm going to ask one more quick question that might seem simple. If
Sure.
there was one thing that you would like everybody to take away today from your presentation, what would that be?
I keep going back to that humble part. When you become a humble mechanic and willing to learn from others is when you're really starting to blossom as a mechanic, because you can't know everything all the time. Learning from others that are more experienced than you is going to really help you in your career. That's what I would say. Always focus on safety and make sure that you're doing that. So,
Okay, James.
My dog says hello, by the way.
That's fantastic. Hey, I can't tell you how much I appreciate your willingness to share this knowledge once again. Again, I thought it was valuable during the VAST conference, and I think it was incredibly valuable today. Really deeply appreciate your willing to give back to the industry like this.
Thank you, Dan. I really appreciate everybody that came and attended and listening in. Appreciate all that. Please take a screenshot of my phone number and email and communicate with me if you need any help.
Really appreciate that as well. And I know that some people missed some of the videos, some of the links you had. I do suggest going back and watching the video. We'll have it up on rotor.org/webinars tomorrow. It'll also be on the HAI YouTube channel. Hopefully both will be up tomorrow afternoon. Sometimes it takes a little bit longer. I can guarantee it'll be up by Monday at the latest.
Sounds
Thanks,
great.
James. Thank you so much.
See you.
Okay, we've got just a few housekeeping things to run through real quick. We'll do that. Save the dates. Our webinars are now every second and fourth Thursdays, unless holidays pop up. Next week, we had a cancellation, so it's going to be, 2 weeks from now, on November 10th, we had a cancellation, so we are going to be scrambling to try and find a new topic. We'll try and get that posted to the website as fast as we can. That's also at rotor.org/webinars. We try to keep everything very simple. November 24th, the fourth Thursday, is a holiday here in the United States, Thanksgiving. We hope everybody who celebrates here in the United States has a peaceful time with their family or whoever you celebrate Thanksgiving with. There's a lot of mechanics on this one, so this December 8th webinar might be just as important. It's the first of a two-parter we are going to be doing. Some of you may be already aware we do military to civilian transition webinars from time to time. That's a huge part of what we do at HAI Heli Expo every year as well. This particular one is for the maintenance guys, the maintenance men and women who are getting ready to leave the military and would be transitioning into the civilian sector. This first part of it is going to focus on what you need to do to get everything prepared to transition. What do you need to do to get your A&P license if you don't already have it? But we're going to be talking with some people from the FAA. We'll be talking with some people, a bunch of people who have already gone through this process, and they're going to share the tips and knowledge that they learned and make it that much easier for you. If you're not in the military now, you might know somebody who's in the military. Make sure you let them know to come in on December 8th and watch that. Right after the first of the year, we're hoping to have the second part, and that would be bringing in some companies who are looking to hire maintenance personnel, and they can help explain to you what they're looking for in terms of experience, maintenance, what should be on a resume, how to get your resume to the top of the stack. Those have been very popular for pilots in the past, and so we think that'll be just as popular for the maintenance personnel as well. We will be sending a questionnaire here very shortly. We ask that you spend just a couple of minutes to let us know what you thought of the webinar today. If there is anything that you would like us to do as a future webinar, I am always looking for topics for other webinars. It doesn't need to be maintenance related, but it does need to be rotorcraft related. We do have some topics coming up on eVTOL, VTOL operations, some of the top people in the industry. And then obviously we try to focus on safety. If you're an HAI member, or even if you're not, but you are interested in what HAI can do for you, send our president a message, Jim Viola. His email address is president@rotor.org. He likes to know what the challenges are that are facing the industry. We know that insurance is a huge one that's facing individuals and businesses. And so we're trying to work on things like that. We're trying to work on workforce development, a number of other areas. We know that people like following the rotorcraft industry. We try to prepare a couple different products here at HAI that help you follow it, make it a little bit easier. First thing we do is Rotor Magazine. It's a quarterly publication, just came out from the presses. It was delayed a little bit for the September issue, but it's an award-winning magazine, and it covers a lot of information. It goes a little bit longer in depth than you'll find in most online articles. The other product we produce is Rotor Daily. It's a daily aggregator of news stories that are related to the helicopter industry or the VTOL industry, the AAM industry, things that are coming. It's the one place that we would have all the news. You don't need to go searching for it. And what we'll do is we send that to your email address every business day during the course of the year. There's usually between 8 and 15 to 8 to 20 stories in each issue. Just makes it that much easier for you to look through, maybe at lunch or when you're on your break. That does conclude our webinar for today. We are grateful that you took time out of your schedule. We know it's tough for the maintenance guys to get off work at times to view these. We are grateful that you were able to find time in your schedule to do it. Until next time, we ask that you fly safe, that you be safe, that you work safely. Thank you very much.